simplify from there. The last one, I'm not really sure if this is exactly what they sent over, but I mean, this is at least what they typed, so I'm just going to kind of work with this. But it is something that, you know, I've noticed a lot of my students really have trouble with is when they have a quadratic, they've totally forgotten how to solve. Now, the nice thing about this quadratic equation is that there's only one x, right? And the x is squared. So we know we need to solve the x squared either by factoring or by using the square root method, using inverse operations, you know, obviously, or the quadratic formula if it's non-factorable and you can't solve, or you can't use inverse operations. But since there's only one variable, I'm just going to use inverse operations, right? We only want to use factoring and quadratic formula when we have like more than one variable that we can't combine. But in this case, since there's only one x, I'm just going to use my inverse operations. So I'm going to subtract a 10. And my goal here is to isolate my x squared. So I get an 8. Now divide by 7. So I get an x squared equals 8 over 7. Now, to undo the square root, I need to do plus or minus, or sorry, to undo the squaring, I need to use plus or minus the square root. So therefore, that's going to be plus or minus the square root of 8 over 7, which again we can rewrite as plus or minus the square root of 8 over the square root of 7. Now, we know that the square root of 8 is 2.8284271. The square root of 7 is 2.6457513. But those are irrational numbers. I am just approximating them. So obviously, those numbers are going to continue going on. But we can simplify at least the square root of 8 to be 2 square root of 2 over square root of 7. Then, typically, at least right now in my class, we can rationalize the denominator here. And we get 2 square root of 14 over 7. So therefore, x equals plus or minus, that didn't go away, 2 square root of 14 over 7.